Hello, today we're going to talk about solving logarithmic equations. But first I would like to explain some of the rules for logarithmic equations. Keep in mind, any a could be any number in these equations. The first rule, called the zero exponent rule, which is that log base of a of 1 equals 0. The second rule states that log base a of a equals 1. The third rule, which is called the product rule, states that log base a of x plus log base a of y equals log base a of x times y. The fourth rule, called the quotient rule, states that log base a of x minus log base a of y equals log base a of x divided by y. The fifth rule, called the power rule, states that y log base a of x equals log base a of x to the power of y. The last rule is the one-to-one rule, which states if log base a of x equals log base a of y, then x equals y. A good example for this rule would be log base 3 of 7x plus 3 equals log base 3 of 5x plus 9. You can cancel out the log base 3 on both sides. You're left with 7x plus 3 equals 5x plus 9. You take 5x away from both sides, and you take 3 away from both sides, and you're left with 2x equals 6. Divide that by 2, x equals 3. The equation we're going to be solving is the natural log base of 4x minus 1 equals 3. First, you need to raise everything to the power of e. That will cancel out the natural log. 4x minus 1 equals e to the power of 3. E to the power of 3 is around 20.085, which equals 4x minus 1. You subtract x, and then you divide by 4, and it should come out that x equals 5.2713.
Okay, so now I'm going to show you a few examples. Solve this logarithm equation. And so this problem does not need to be simplified because there's only one logarithm in the problem. We have to rewrite the problem in exponential form by moving the base of the logarithm to the other side. And so that will be rewritten as 4x
plus 11
equals 5 equals 5 to the power of 2. And then we have to simplify that, so 4x plus 11 equals 25. And then we have to subtract 11 from each side. And then you get 4x equals and then you have to divide each side by 4. X equals 7 over 2, and that's because it reduces. Equation right here. And this problem contains terms without logarithms, and this problem can be simplified by using property 4, which changes the subtraction of logarithms to division. And so we can rewrite this as log base 2 x plus 1 over x minus 4 equals 3. And so now we can rewrite this by putting everything to the power of 2, and this is because this will cancel out. And so it'll be x plus 1, x minus 4 equals 2 to the power of 3, which is 8. And we multiply each side by x minus 4. And this will cancel out on that side. So we're left with x plus 1 equals 8 times x minus 4. Now we distribute the 8. X, we write that. 8x minus 32. And then we have x minus 8x equals negative 32 minus 1, and that's negative 7. X equals negative 33. We divide each side by negative 7. And we get our answer to be x equals 33 over 7. You can stop it. Okay, so here's another problem. And for this problem, since we have addition here of logs, we can multiply this x and x plus 6 because they have a common base. So we can rewrite that as log base of 8 x plus 6 equals log 8 5x plus 12. And since the bases are equal to each other, we can drop them. So it would be x plus 6 equals 5x plus 12. We distribute this x, so it's x squared plus 6x equals 5x plus 12. We move over the 5x and the 12, and we are left with x squared plus 6x minus 5x equals minus 12 equals 0. And so it would be x squared plus x minus 12 equals 0. And now we have to factor that. It would be x minus 3x plus 4. We are left with x equals 3 and x equals negative 4. And negative 4 really won't have a solution. And so your answer will be x equals 3. Okay, so now we have this equation right here. And from property 5, the power rule, we learned if we have a coefficient in front of the log, then we can rewrite it as log base 10, because when we have log like that, we assume it's log base 10 of 10 to the power of 2. And so equals x, and we can distribute that, so it would be log 100 equals x, and then x would be 2. Also, another way that we could do this, we have our equation 2 log base 10 equals x. And so from one of the rules that we learned was that if we have log base of 8 to the power of 8, that equals 1. And so if the bases are the same, like we have that one, that would equal 1. And so it would be 2 times 1 equals x. And so 2 times 1, x equals 2. And you would have your same answer. Thank you for watching, and now you know how to solve logarithmic equations. And remember, while working on logarithms or logs, try not to get stumped. Ha ha ha.